You should have the two questions answered on your warm-up. You're simply identifying whether the function is an exponential growth or an exponential decay. Remember that to determine if it's an exponential growth or decay, you're looking at the base. The base is the number attached to the exponent. So in the case of number 1, we're looking at 0.75. The 2 we're going to ignore for right now. The 0.75 is a number less than 1, which means this is an exponential decay. Number 2, the base that's in this problem, is the 3, because again, that's the number attached to the exponent, not the 0.75. 3 is greater than 1, which means it is an exponential growth. So make sure you've checked your two answers, fixed them if they're wrong, marked them correct if they're correct. Here is your homework from last night. Mine might be numbered a little bit differently, but they should just be the first set of problems on your worksheet. Number 1 and 2, you're graphing. Remember, there's the asymptote for these y equals 0. There were some negatives for you to fill in. Remember, negative exponents turn things into fractions, and they divided the fractions, which is where they got the decimals. Five through 10 is like what we practiced on the warm-up. And then number 18 is using the formula for exponential growth that we learned at the end of the lesson yesterday. So go ahead and check these through, pause the video as needed to check all of your answers, and then unpause when you're ready to go over today's notes. Today, if you look in your workbooks, we're going to be looking at section 4.7. I know that's a big jump from 4.1, but we're just trying to keep it all together with the graphing. So today what we're going to talk about are transformations of exponential functions. The first thing is we have what we call a parent function. Remember, we talked about at the beginning of the first 9 weeks, parent functions, they're what every variation is based off of. So a parent function for exponential is when you simply have a number, a base, raised to an exponent. There's nothing being multiplied, there's nothing being added or subtracted. That's your parent function. Y equals 2 to the x, you've seen already, but we're going to go ahead and do that. We are going to use some negatives here. So I'm going to go -2, -1, 0, 1, and 2. If I put -2 in for x, I get 2 to the -2, which means 1 over 2 to the -2 to the 2, because when we move the exponent from the top to the bottom when it's negative, it becomes positive, and 1 and 2 squared equals 1/4. So in the table you could either put 1/4 or what 1/4 is equal to, which would be 0.25. Now we're going to do the same thing with -1. So 2 to the -1. Well, that negative exponent means 2 is going to go to the bottom, and 2 to the first is just 2, so 1/2. Or 0.5, depending on what you prefer. The next ones are a lot easier. So we have y equals 2 to the 0. Remember, we talked about yesterday, anything to the 0 power is simply 1. Then I have 2 to the first. 2 to the first is just 2. And last but not least, we have 2 squared, which is 4. So now we're going to graph these points. So negative 2 and 0.25. So negative 2 and then 0.25 will be just a little bit up. Negative 1 and 1/2, it's going to be a little bit further up from that. Then we've got zero and 1. One, 2, and then 2, 4. So we know it's going to curve. And then on the left, it's going to approach the asymptote. And hopefully we remember the equation for the asymptote is y equals 0. So this is one of your parent functions for exponential. That 2 doesn't have to be a 2, it could be a 3 or 4 or 5, but it's the fact that there's nothing else in that equation besides 2 to the x. When it's a parent function, it's always going to approach y equals 0, but never actually reach it. So now we've got several equations that we're going to graph and then explain the type of transformations that happen. Transformations mean that it's changed. It's no longer exactly like the parent function. So if you look at the first one, it shows us that we're multiplying something times 2 to the x. So we're going to use our same values here. Negative 2, negative 1, 0, 1, and 2. Well, we know from the parent function, we know all of these values, so we just have to take these and multiply each of them by this 0.5. So I'm going to start with the last one, which is the 4. Well, if I take 4 and multiply it by 0.5, that's going to give me 2. And again, we're multiplying by 0.5 because of this part here. Well, when I put in 1, I got 2, but this equation says to now multiply it by 0.5. Well, 2 times 0.5 is 1. Next, I got a 1. Well, if I take 1 and multiply it by 0.5, 1 times 0.5 is 0.5 or 1/2. When I had negative 1, I got 1/2 or 0.5, and I'm now multiplying it by 0.5. So 0.5 times 0.5 would be 0.25. And then the last one, I had gotten 1/4 or 0.25. So I need to multiply the 1/4 or the 0.25 times 0.5, and that should give you 0.125. So notice the numbers got smaller in the y column. So we're going to graph these numbers. So negative 2, and then 0.125 is going to be just above that. And then we have negative 1 and 0.25, so that's pretty much just above that one. 0 and 0.5, and then we've got 1, 1, and then 2, 2. It still is going to be approaching that asymptote of y equals 0. Well, if I look at what happened and compare it to our original parent function, you'll notice the curve is just a little bit wider, And when it's wider, we call that a compression. And it's the number that we multiplied by that's the compression. So it's a compression of 0.5. If you notice, it didn't go up or down any from the original one. It's still approaching the 0 and then the same spot again, just a little bit wider of. So this is a compression of 0.5. So if you remember from the first 9 weeks, we had the same rule. Any number that's between 0 and 1, so those are your 0.5s, your 0.25s, your fractions in between 0 and 1, are compressions. If we talk about a stretch, is going to be a number greater than 1. So 1.25 or 2 or 4 or 5, all of those are stretch numbers. Numbers in between 0 and 1 are your compression numbers. And again, that's the same rule that applied the first 9 weeks. Going over to the next graph, if we compare the equation to the parent function, remember your parent function for this is y equals 2 to the x. So I look at what's different from here to here, and the thing that's different is this negative sign. Well, we talked about negatives being multiplied. Again, in the first 9 weeks, everything builds in Algebra 2, just like Algebra 1. So that negative we use as a reflection, which means instead of the curve going up, the curve's going to go down. So now we take each of the numbers that we got from the chart. So if we plug in our -2, -1, 0, 1, and 2, remember in the chart, all we're doing is we're changing it to be multiplied by negative because of that negative on the outside of the 2 there. So our first was 0.25. So if I multiply that by negative, that means we have negative 0.25. If you look at your number next to -1, it was 0.5. So we multiply that by negative, so that's negative 0.5. In the chart, when I plugged in 0, I got 1. So that means this is going to be a -1. When I plugged in 1, the original parent function had a 2 there, so that means this will have a -2. And last but not least, when I had plugged in 2 on the first one, we got a 4, so this one's going to be a -4. So go ahead and graph these points. Take a moment to do that, and then unpause the video to make sure that you graphed them correctly. So -2, -0.25 should have been right about there. -1 and -5, -0.5, 0 and -1, 1 and -2, and then 2 and -4. So you can see the curve going down here. You can see on the left side it's still approaching 0, so there's our asymptote. And it's still y equals 0. So this one, the transformation, again comparing it to the original one. So this is our parent function. Here's our new one. And the only thing that changed is that it reflected so when you have a negative in front, it's a reflection over the x-axis. So we've seen the compression and then talked about what the difference would be for a stretch, and now we've seen a reflection. So let's look at our next type. We have y equals 2 to the x minus 4. Now if you notice, remember our original parent function is y equals 2 to the x. So I look at the difference between the parent and our new function, and the difference is this minus 4. Now hopefully you remember from the first 9 weeks, when we have the number being added or subtracted in the parentheses, that is our horizontal shift, and we're going to show that here. So with this one, we actually have to plug the numbers in one at a time. We can't just multiply the numbers from the original chart since we have parentheses here. So we're going to be plugging in the same values for x. Now if I were to plug in -2, let's think this through here. I would have -2 minus 4, which is -6. So if I put that in as an exponent, that's going to be an incredibly small number since it's going to turn into a fraction. So we're going to change these numbers up a little bit. So if I'm subtracting 4, to go with a number that would be pretty easy to work with, I'm going to go 2, and then 3, 4, 5, and 6 is my numbers. Now, the reason I'm doing that is because we're subtracting 4 from each of these numbers, and that's going to become our exponent. And we don't want to have too big of an exponent because we can't really graph those. So for y equals 2x minus 4, if I plug in a 2, it's going to be y equals 2, and then in parentheses 2 minus 4. So that's going to be 2 to the -2, which means 1 over 2 squared, and 2 squared is 4, so we have 1/4, or 0.25. Next I plug in 3, so y equals 2 to the 3 minus 4. 3 minus 4 is -1. So that means 1 over 2 to the first, and that's 1/2, or 0.5. Then I plug in 4, y equals 2 to the 4 minus 4. 4 minus 4 is 0. 2 to the 0 is 1. Hopefully you're remembering that. So next we have plugging in 5 and 6. So y equals 2 to the 5 minus 4. 5 minus 4 is 1. So we have 2 to the 1, which is just 2. And then last but not least, we have 6. So y equals 2 to the 6 minus 4, which will be 2 to the second, which is 4. So now we're going to graph these points on our graph and see how this changed from the original parent function. So we've got 2 and 1/4, so it's going to be over here. 3 1/2, 4 and 1, 5 and 2, and then 6 and 4. So we still got our curve, we're still approaching that 0. Having a hard time drawing this approaching 0 line. Bear with me. So we still have the asymptote of y equals 0. So if I go back and compare this to the parent function, you'll notice that the graph has shifted to the right, if you look at where our dots are. So this is a horizontal shift. Right. And you could count, but if you look at the number in the parenthesis, that tells you how many units. Now, let's talk about how we know which direction it goes, left or right. We know it's horizontal because it's in the parentheses. And remember, horizontal, what's in the parentheses is always the opposite. So since it was minus, we do the opposite of that. Minus usually means left or negative. The opposite means right or positive. So another example, if you had x plus 4, then that would mean left 4 units. So we have one more type of transformation to look at. And we've got y equals 2 to the x and then minus 3. Notice that minus 3 is not in parentheses, and it's not an exponent. Well, if I look at my original parent function, and I compare the new one, you'll notice the difference is this minus 3. So we're going to see how that affects the graph here. I'm going to go back to my original exponent since I'm not changing them any. So negative 2, negative 1, 0, 1, and 2. So this one says we're going to take each of the values that we got in the original chart, the 2 to the x, and then we're going to subtract 3 from them. So our first value in the chart is that 0.25. So if I have 0.25 minus 3, that's going to be negative 2.75. The next number in the chart was 0.5. 0.5 minus 3, that's going to be negative 2.5. The next number in the chart for 0 was 1. 1 minus 3 will be negative 2. The next number in the original chart was a 2. 2 minus 3 is negative 1. And the last number in the chart when I plugged in 2 was 4. So 4 minus 3 will be 1. So here are my new values to plot. So negative 2, negative 2.75 is down here. Negative 1 and negative 2.5 is a little bit above that. 0 and negative 2. 1 and negative 1. And then 2 and 1. So you can see our curve. And you can see where it's going to level out. Now this time it's not leveling out where y equals 0. It's leveling out on this line here. So I still have to have the equation y equals, so I count down to 3. So I know that this asymptote is y equals negative 3. Now, can you compare that to the equation for this? Hopefully you notice that this number and this number match. So those will always be the same with that number and its asymptote. So now, comparing this to the original function, you'll notice that instead of being above the 0, it's now below it. And you'll notice that it went down 3 units. So this one is still a shift, but it's no longer a horizontal shift, it's a vertical shift. It's not in parentheses, so we don't do the opposite. So it's a vertical shift down 3 units. So continuing on in the same thread as the rest of them, an extra example. If you have 2 to the x plus 3, then you would have a vertical shift up 3 units. So those are your type of transformations: compression, stretch, reflection, and then horizontal and vertical shifts. Now you're not always going to be graphing them. Most of the time you're simply going to be labeling the original, or labeling the transformations, which is what we're looking at next. We're going to do 2 together here, and then you're going to try some on your own. Now remember, the number that we're not concerned with in identifying translations or transformations is this number, the base. The base tells us the exponential growth or decay, but it does not tell us anything to do with the transformations. So I'm going to go ahead and cross out that 2. So I look at what else is in that equation, and the only other thing is a 0.3. So the 0.3 is being multiplied, which means it's either going to be a compression or a stretch. So compression means the number being multiplied is between 0 and 1, and stretch means the number being multiplied is greater than 1. Well, 0.3 falls between 0 and 1, which means this is a compression of 0.3. There's nothing else in that equation, so that is the only transformation that we need to identify. Moving over to the example on the right. Remember, the base, the number that's being attached to the exponent, is not part of our transformation, so this time the 0.3 does not matter. So I look at what else is going on here. Well, there's a negative here. Negative is always a reflection. And with exponential functions, the reflection is always over the x-axis. But that's not the only part of my equation. There's also this part right here. Now, please be careful here. This is not in parentheses, but it is still part of the exponent. So because it's part of the exponent, it's still a horizontal shift. And because it's part of the exponent, and technically it is in parentheses, we do the opposite. So minus would typically mean we move left, but the opposite would mean move right. So horizontal shift right 2 units. I want you to go ahead and try the next 2 U-tries, and then we'll go over them before you finish out the day with the last 2 U-tries. Right, you should have both U-tries done that you started with. So let's start with the first one. Remember, the number that's the base does not affect us in transformations. It only affects us in growth or decay. So I've got a negative, I have a 2, and then I have a plus 3. So here you should have had 3 different transformations listed. Let's start with the negative because that's the easiest one. That means a reflection over x-axis. The 2 is being multiplied, so that means either stretch or compress. 2 is greater than 1, so you should have had a stretch of 2. And then the last thing to label is that plus 3. Since the plus 3 is part of the exponent, that means it's horizontal. Horizontal is the opposite. So plus 3, the opposite of that would be minus, which means left 3 units. And we should have the word shift in there. So there's your 3 transformations for this parent function. Going over to the next utri. Hopefully you realized that the number that we did not have to do anything with was that 3 because that's the base. So I need to talk about that negative first. Negative, again, always means reflection. And it's over the x-axis. The next thing I come about is a 2 here. That 2 is being multiplied, so again that means stretch or compress. It's a number greater than 1, so it's a stretch of 2. The next number I run into is the plus 1. That's part of my exponent, so that means horizontal shift. Doesn't matter that it's not in parentheses, horizontal is the opposite. So since it's plus, that means the opposite, so it means left, because that's a negative direction, 1 unit. And then we also have this minus 5 at the end. Since the minus 5 is not part of the equation, or sorry, part of the exponent, that means vertical. Vertical does not work on the opposite, it's the same. So it's a vertical shift. Since it's negative, that means down 5 units. So this one had 4 different types of transformations. You might be running out of time in class, hopefully not. If you are, then make sure you try the 2 utris, and you can watch this video online tonight to check your answers. If you're not running out of time, then go ahead and do those 2 utris and then unpause the video to check them. Alright, here are your answers to the utris, the last ones. First of all, the 2 is the base, so we don't count it. So we've got a 3 here. Multiplied means stretch or compress. It's a stretch because it's greater than 1. Next, we have the minus 1 that's part of our exponent. Since it's part of the exponent, that means horizontal. Shift. Horizontal is the opposite. So instead of going in a negative direction, we're going to the right in a positive direction. And then we also have the plus 4. That's not part of your exponent, so that's vertical. Plus for vertical means up. Last one. The number you should not have worried about is the 1/2. There's only one other number in this problem, and that's the 0.25. That's being multiplied, so that means stretch or compress. 0.25 is between 0 and 1, so that means a compression of 0.25. And there's the last answer to your review try.